Hi, my name is Aditya, and I'm working with my friends Nick, Anand, and Arjun to teach you a thing or two about chemical reactions happening in us and around us. First thing we're going to be talking about is photosynthesis, which is the process by which plants take in the carbon dioxide that we breathe out and produce oxygen and energy for themselves. Secondly, we'll be talking about cellular respiration, which is a reaction in which we take in the oxygen that the plants give out, breathe out carbon dioxide, and produce energy for our bodies. And the third thing that we're going to be talking about is chemical reactions that happen around us, such as the striking of a match. And finally, we'll be talking about the pH in different objects to know if they're acidic or basic and how those different things will affect us if we were to touch them or taste them.
Hi, my name's Nicholas, and I'm going to be talking about photosynthesis in nature.
Hi, my name is Aditya, and I'm going to be talking about cellular respiration in our bodies.
Hi, my name is Anand, and I'm going to talk to you about combustion in nature.
My name is Arjun, and I'm going to talk about pH in nature.
As you may know, photosynthesis is the process by which plants create energy. And the equation is... The products of this equation are C6H12O6, which is sugar, and 6 molecules of oxygen, which animals use to breathe, and sugar is used for energy by all animals. Without these essential parts of photosynthesis, there wouldn't be life on Earth. You see, the world is interdependent, and not one organism can live on their own. For example, plants depend upon animals to release carbon dioxide, and then they use the sun to produce sugars and oxygen, which in turn is used by us for energy. I love fresh air, and fresh air is produced by plants such as this one. They take in our harmful products such as carbon dioxide and carbon monoxide, which is released by cars, and they release oxygen, which is essential to our well-being. Now I think I'm going to go on a bike ride.
Hi, my name is Aditya, and I'm going to teach you about chemical reactions in our body. The main reaction constantly happening in our body is called cellular respiration. This is the chemical equation. C6H12O6, or sugars, plus 6O2, oxygen gas, equals 6CO2 plus 6H2O, carbon dioxide and water, plus energy for your body. As you can see, your body takes in sugars and oxygen and produces carbon dioxide and water. As Nick just mentioned, plants have a similar but opposite reaction in which they take in carbon dioxide and give out oxygen. This allows us to live together. If you go on a walk in a park, you realize the difference than the walk in the city, because of the walk in the city would have tainted air. This is only one of the chemical reactions occurring in your body every second, but it is the most important to sustain our lives. Oh hey, didn't notice you there. Isn't it great to go on a nice bike ride once in a while? Did you know that just going on this bike ride, or going for a nice jog, uses a process called cellular respiration? In this process, your body takes in oxygen that you breathe and sugars from the food you eat and produces carbon dioxide, water vapor, and energy for your body. If you play a sport, you know you should always eat a good meal before a game. That's because your body takes time to break down the food in your stomach and produce the sugars needed to start the reaction. You also need to drink a lot of water to break down these same sugars. In turn, you also need to breathe in oxygen to help start the reaction. As a result, you get the energy that you need to run or do whatever you need to do for your sport, and also you breathe out water vapor, which goes back into the air in our atmosphere.
That was a nice bike ride. Now back to photosynthesis. Photosynthesis is just a big word to help describe the process by which plants get their energy. They take in water, sunlight, and CO2, or carbon dioxide, to produce sugars and oxygen. The sugars are used by the plant to give them energy, and we breathe in the oxygen. Another nice factor with sunlight is that it helps to produce this beautiful hue of green, which you see in almost all plants. This green is produced by the chloroplasts within the plants. Another thing that's essential is a water source. All plants need water, so they're generally located around a nice water source such as this pond here. Another thing you can see here is that there's algae growing in the water. This algae uses the water, which obviously has an unlimited source of, And the sunlight, which you can see cast down, is used to give the plants energy and also to help release oxygen. As you can see, there are air bubbles slowly coming out of this. A nice thing with algae is that it produces 90% of the world's oxygen, specifically blue algae, which is found in the oceans and many salt lakes.
Hey guys, I'm going to talk to you about combustion in nature. Fire is a prime example of combustion in nature. This example of a combustion reaction is a butane reaction. The equation of a reaction is C4H10, or butane, plus 13O2, or oxygen, yields 8 carbon dioxide, or CO2, and 10 H2O, or water vapor. The reaction that goes on inside of a car's engine is a combustion reaction as well. Oxygen, or O2, is a reactant, and the products are water, H2O, and carbon dioxide, CO2. Cellular respiration is affected by the fumes that cars give off and the products that fire gives off as well. When we ignite the paper with this butane lighter, the reactants will be oxygen and carbon, and the products will be heat and CO2. I'm going to talk to you about how a chemical reaction in a match works. The match that we were using is composed of a wooden base and a match head made out of phosphorus sulfide, or P4S3. Matches require friction to work, so when friction is applied, the phosphorus sulfide reacts with the oxygen in the air to create a flame. The fire from the flame releases carbon dioxide, carbon monoxide, and water vapor. This is another example of combustion reaction.
I'm going to teach you the specific chemical changes and reactions involved in lighting a match. Most matches are composed of a sulfur, a phosphate, and a friction agent such as glass powder inside the tip. It is rubbed against a strip of red phosphate. The friction agent causes heat, which changes the red phosphorus on the strip to white phosphorus, which chemically reacts with oxygen in the air to produce a flame. As you can see, most of the strip is made of red phosphate, but where it was rubbed upon has some traces of white phosphate. The flame ignites the match tip, which in turn creates a sustained fire as it lights the wood of the match. Strike anywhere matches are almost the same, except the match has red phosphate on the tip, which creates friction with any surface it is rubbed upon, creating the same friction with oxygen in the air, creating the same reaction with oxygen in the air, creating a fire. With regular matches, you'd have to strike it upon the box to create this beginning spark, such as this. But with strike anywhere matches, you can rub them on any surface that would create the same amount of friction, producing the heat that starts the reaction, such as this.
Hey guys, I'm going to talk to you about fumes and reactions of a car. The emissions that a car produces are acidic when they react with water vapor in the air, which can turn into acid rain. Unpolluted rain has a slightly acidic pH of 5.6 because carbon dioxide and water in the air react together to form carbonic acid, a weak acid. When the pH levels of rainwater go below 5.6, it's generally considered acid rain. Acid rain is a harmful product that cars and factories can create with their fumes and emissions. The reactions inside of a car are combustion reactions, which is run by a main reactant, gasoline. Gasoline consists mainly of hydrocarbons, which when mixed with oxygen yields carbon dioxide, carbon monoxide, and water vapor. It takes heat to complete the reaction, which makes it a combustion reaction. A car engine uses this reaction to push its pistons. Inside the piston chambers, the gasoline is sprayed into the air and then ignited. The reaction heats it all up, making the air how our engine converts the gasoline's chemical energy into mechanical force.
Hi, my name is Arjun and I'm here to help you learn about pH in our environment and how it affects us. Acids are readily found around us in our households and foods. Lemons, such as this one, are acidic. You can tell because of their sour taste and the strong smell. They also sting if they come in contact with your eyes or if they get in cuts. Most household cleaning products, such as this window cleaner, are very basic. If I were to get some of this on my skin, it would give me a rash.
In order to survive, these plants must be in soil with a pH greater than 7. If the soil is too acidic, these plants' roots will be damaged and they won't be able to survive. In order to measure the pH of the soil, one first needs to use either litmus paper or a tester to find the hydronium ion concentration in the soil. After that, one can take the negative log of this and they will get the pH. As you can see, pH is very important, not only in the world of chemistry, but also in biology. Alright, so I'm back from my backyard, and now I want to figure out the pH of my soil, so I know whether or not the plants can survive. So, suppose that using infrared scanning, which is a technique used to determine hydrogen ion concentrations, I determined that the hydrogen ion concentration is 1.0248 times 10 to the negative 9. So, because we know that pH is equal to negative log of the concentration of hydrogen ions, I can simply plug in 1.0248 times 10 to the negative 9 into the equation to get the pH is 8.98, 940,320. Therefore, I can now see that my plants will be able to survive because they only need a pH of 7 and or higher. Therefore, I can safely plant my plants and they will be able to survive. This is the power of chemistry in nature.